Let's look at finding the horizontal asymptotes of the following function if they exist. So our function f of x is x cubed minus 5x over 4x squared. And recall that the definition of horizontal asymptote is the line y equals L is a horizontal asymptote of the graph of the function f of x if the limit as x approaches negative infinity of f of x equals L, or the limit as x approaches positive infinity of f of x equals L. So notice that our function here is a rational function. So we should be able to take advantage of this property that the limit as x approaches either positive or negative infinity of a constant c, which could be any real number, over x to the r power, where r is a rational number, equals 0. So you may have seen before the strategy of taking the degree of the denominator and multiplying both numerator and denominator by, in this case, x to that degree. So what we see here is in the denominator we have an x squared. So as we go through the process of finding the limits here, we will want to multiply both numerator and denominator by 1 over x squared. So let's go ahead and get started. Let's first consider the limit as x approaches positive infinity of x cubed minus 5x over 4x squared. So we're going to want to multiply both numerator and denominator by that 1 over x squared we discussed. Now, notice that we're simply creating an equivalent function that behaves similarly to the one we started with. And this is all well and good because basically we're multiplying by a cleverly defined number 1. And we don't have to worry about x being 0 and causing issues with the denominator because our limit is as x goes to positive infinity. So x equals 0 will not be causing any issues for us. So let's go ahead and use the distributive property to multiply this out. So we'll have the limit as x approaches positive infinity. 1 over x squared times x cubed is going to give us x cubed over x squared. And 1 over x squared times minus 5x, so minus 5x over x squared. We'll get it there. X squared all over, and then we multiply the denominator as well. 4x squared times 1 over x squared. Okay, so let's do some simplifying here. We have x cubed over x squared, so that's going to simplify to x. So we have the limit as x approaches infinity of x minus 5x over x squared will simplify to 5 over x, and then 4x squared times 1 over x squared. The x squareds will divide out. We get a 1, so this is 4 times 1, or just 4. Okay, and notice how nicely that multiplying by 1 over x squared gives us a nice constant in our denominator. It's very helpful. Okay, so we're taking the limit as x approaches infinity. And so this is kind of interesting. This is kind of like as x approaches infinity, x in my numerator approaches infinity. So I'm going to put that in quotes. It's headed towards infinity minus my 5 over x. As x approaches infinity, this will approach 0. So we're going to have a 0 over 4. So what does this equal? So my numerator is growing without bound. I'm subtracting nothing from it and then dividing by 4. So this quantity will continue to grow without bound. That dividing by 4 just slows it down a little bit. So the limit as we head to positive infinity is positive infinity. So we don't have a line y equals L. So that headed out to positive infinity, there is no horizontal asymptotes. So let's go ahead and see what happens when we head out to negative infinity. So the limit as x approaches negative infinity of x cubed minus 5x over 4x squared. Well, notice that we're going to basically use the same process that we did in terms of creating an equivalent function. We will still be multiplying by 1 over x squared in the numerator and the denominator. And again, we won't have any issues with the denominator, x being 0 or the denominator being 0, because we have x headed out to negative infinity. So this step here is quite similar. So is this, using the distributive property. So I'm going to go ahead and jump to this more simplified form that we created above. This is the limit as x approaches negative infinity of, after we do some simplifying there, we get x minus 5 over x all over 4. Now, as x approaches negative infinity, this x in the numerator will also approach negative infinity, and this minus 5x will approach 0. So we have something a little different than what we had before. Instead of positive infinity, we'll have negative infinity minus 0 over 4, which is still going to give us negative infinity. So what happens with this particular function is we have not been able to identify any constant L for which either of those limits exist. When x headed to positive infinity, we got positive infinity. When x headed to negative infinity, we got negative infinity. And we can see that behavior in the graph of the function here. As x approaches positive infinity, we can see that function continuing to grow. And as x approaches negative infinity, we can see that function continuing to decrease. So this particular function has none, have none. There are no horizontal asymptotes, so none exist.